taking up a few numerical problems on discrete time systems and their transforms. So, let us start with the first question. The response of an LTI system is given here. For an input of 1, 0, minus 1, the output sequence is 1, 0, minus 1, 0, 1, 0, minus 1, 0, it continues. You determine the impulse response. Of the system. Determine the impulse response of the system. Okay. So, let us see, if we apply Z transform, then what will be x z? What will be x z? 1 minus z to the power minus 2. What will be the corresponding y z? 1 minus z to the power minus 2 plus z to the power minus 4 minus z to the power minus 6 and so on. Okay. So, this is an infinite sequence. This will be giving me 1 plus z to the power minus 2, okay. Z to the power z magnitude should be less than 1, that is ROC. So, what will be Hz? Yz by xz. There is some noise. One plus z to the power minus 2 into 1 minus z to the power minus 2. That will be 1 minus z to the power minus 4. So, what will be the inverse of this? You are very familiar with this. It will be 1, 0, 0, 0, minus 1 or plus 1. If it is minus, then in the series it is basically z to the power minus 4 with plus signs. So, it is a sequence like this. Okay. This will be the impulse response. Now, next example is, there is a sequence given 2 root 2 0 minus root 2 minus 2 minus root 2 0 root 2. This is just one period of a sequence A sin omega naught n plus phi. Can you determine A, omega naught and phi? One may detect it by inspection, but we will solve it by rigorous mathematical technique. Let me see, first of all, this set of values. First one is 2, next one is root 2, next one is 0, next one is root 2, next is minus root 2 of course, then minus 2, then again minus root 2, then 0, then root 2. Next it repeats again at this point. So, this is the period. Okay. You sketch it in the form of a sinusoidal function. Now, can you tell me what will be A from here? What is the expression for this? Okay, A is equal to 2, and then what will be the function Hn? You may be able to write it, we will solve it, because the sequence could have been something else also. Here it is very simple. So, this is 2 pi, okay. This is 0, this is the radian frequency omega. So, 2, is it a sine function? Cos function. So, in terms of sine, how much is omega naught? How much is omega naught? How much is this? So, 2 pi by 8. This is 45 degrees, 90 degrees. So, 2 pi by 8 n, all right. And how much is the phase shift? Plus or minus? How much is the phase shift? Plus or minus? Plus pi by 2. Is that all right? So, it will be 2 sine pi by 4 n plus pi by 2. Okay. So, let us see how we solve this analytically. Put n is equal to 0. So, A sin phi, that is equal to 2. Next, A sin omega naught plus phi is equal to root 2. No? This is equation 2. A sin twice omega naught plus phi is equal to 0. Okay. Is that all right? So, substitute from here in the second equation. The second equation is A sin, break it up, omega naught cosine phi plus A cosine omega naught sin phi is equal to root 2, and A sin phi is 2. Okay. So, if I put A sin phi is equal to 2, this A sin phi will become 2. So, A cos phi sin omega naught plus 2 into cos omega naught is equal to root 2. So, this is modified equation 2. What about the third equation? A sin 2 omega naught cos phi plus A cos 2 omega naught sin phi is equal to 0. Okay. Put it to this side, A will get cancelled, okay, or okay, retain A sin omega naught cosine omega naught cos phi, okay, into 2 plus a sin phi is 2 cos omega naught squared twice, sorry, cos square omega naught minus 1 into 2 is a sin phi is 2 is equal to 0. Now, from this one and this one you can eliminate a if you try to substitute this here, you will finally get a sin pi by 4 plus phi is equal to root 2, and from there another equation will get, before this, 2 root 2 cos omega naught equal to 2, from where you get cos omega naught is equal to 1 by root 2, and hence omega naught is equal to pi by 4. Okay, that has been substituted here. You will get this relation first by elimination, okay, and substitute it here, this will be root 2. So, from there you can compute phi, okay. There is one relationship, a sin phi is equal to 2, and this one if you expand and then substitute this condition, you will get 2 cot of phi plus 2 is equal to 2. You just expand it, a sin pi by 4 is 1 by root 2, that 1 by root 2 I shift here, cos pi by 4 is also 1 by root 2. So, the 1 by root 2 term if I put here, that will become 2, and on the left hand side you will get this. Whence cot phi will come out to be 0. So, phi is pi by 2. So, it will be a sin n pi by 2, sorry, n pi by 4 plus pi by 2, which means of course cosine. Is that all right? Let us take up another example. I think I should change the pen. You are asked to determine yn, which is the convolution of xn and hn. Okay. Xn is given as n greater than equal to 0, n less than 0. Actually, I can put greater than 0, because when n is equal to 0, it automatically becomes 0 at x equal to 0. So, this equal to sign in this particular case does not have any significance, it may be just greater than. And hn, what is this function by the way? It is a ramp function. Okay. Hn is minus 1 to the power n greater than equal to 0 for n less than 0. The purpose of defining any function in these two ranges is to just avoid writing un, otherwise you can write n into un, you do not have to put all this. Okay. Similarly, this one. So, let us just sketch the functions. One is like this 1, 2, 3 and so on. This is x n. The other one is h n, all right, which will be alternately plus 1, minus 1. Does it start with plus 1? N is equal to 0, it will be plus 1, minus 1 and so on. Okay. So, let us see what will be the response corresponding to this. This is h n. Now, using Z transform, you are asked to find out the response using Z transform. Okay. So, x z is sigma n z to the power minus n, all right. So, you remember this is z dz of sigma z to the power minus n, which is minus z d dz of, for z to the power minus n, what is the sum? 1 by 1 minus z inverse. So, that we can reduce it to this form also, just multiply throughout by z. So, take the derivative, that gives me z minus 1 into 1 minus z, is that so, divided by z minus 1 whole square, z into derivative of this, that is 1. So, that will be minus, z will get cancelled. So, minus 1 and minus will make it plus z by z minus 1 whole square. Is it okay? What will be h n, h z? H z will be 1 by 1 plus z inverse, which means z by z plus 1. Okay. So, y z will be the product of x z and h z, that will be z square by z minus 1 whole square into z plus 1. Is that so? So, take the product and make a partial fraction. So, z minus 1 whole squared into z plus 1. I can write this as a by z plus 1 plus b by z minus 1. Okay. Sorry, I will take y z by z. Whenever you are having the function in terms of z, not z inverse, in terms of z, then it is better to take y z by z as the partial fraction y. After getting a b c, I will multiply z here, then a z by z plus 1, it is a standard form, b z by z minus 1, c z by z minus 1 whole square, we know the corresponding values, okay, values of y n's. Similar thing you have done in network synthesis also. Remember RL circuit, you take ZS by S first, make the partial fractions and then get ZS. So, what will be A? It will be multiplied by Z plus 1 evaluated at Z equal to minus 1. So, if I multiply this by Z plus 1 and divided by Z, so it becomes Z by Z minus 1 whole square at Z is equal to minus 1. So, that gives me minus 1 by 4. Is that all right? Similarly, C, let us evaluate C first, because that takes all the multiple roots. C, it will be yz by z, z minus 1 whole squared. So, that gives me z by z plus 1 to be evaluated at z is equal to plus 1. So, this will be 1 by 2, and it is this function which is to be differentiated with respect to z. So, for the evaluation of b, and if there are more number of roots, then you start with the highest term with the highest number of roots and then keep differentiating. So, b will be d dz of z by z plus 1 and evaluated at z is equal to 1. So, that gives me again 1 by 4. Is there any other opinion about this for evaluation of b? Subtract a by z plus 1 and c by z minus 1 whole square from this side, you can straight away get b by z plus 1. You do not have to take the derivative. No, is it not all right? So, yz will be az by z plus 1 plus bz by z minus 1 plus cz by z minus 1 whole squared. Therefore, yn, if you take the derivative, if you take the inverse of this, az by z plus 1, how much is it? A into minus 1 to the power n plus b into 1 to the power n, okay, plus c into n. Just one or two problems earlier we have derived this, is it not, for the ramp function. So, whole thing multiplied by un, and now substitute the values. A is 1 by 4, okay, into minus 1 to the power n. You can write minus 1 by 4 to the power n. Can I write like that? Should it be minus 1 by 4 to the power n? No, this is all right. Okay, plus 1 by 4 plus half n whole thing into un. Is that okay? A was minus 1 by 4, so there will be a minus sign here. Is that all right? This is the one you are talking about. Next, let us take another example on z inverse, z by z square plus 4z plus 13. This is a very familiar problem. We know z transform of a to the power n sin bn. How much is that? Z a sin b divided by z square. No, if I write in terms of z, then it will be z square minus 2a cosine b into z plus a squared, if you remember. So, straight away matching the coefficients, a square is 13. Do you all agree? So, a is equal to root 13. How much is a cos b? Minus 2a cos b is 4. So, it will be minus 2. So, what will be A sin B? 13 minus 2 square 4, 9 under root. So, 13 minus 4 under root, so it will be 3. Okay. A square, this squared plus this squared is 13, and that is equal to A square. A sin B is 3, is that all right? So, tan B is minus 3 by 2. Is there anything wrong? Therefore, Z inverse Z by Z squared plus 4Z plus 13 will be, I can put 1 by 3 here and 3 into Z there, divided by Z square plus 4Z plus 13. I can write this as Z inverse of this, and which is nothing but, I have made it in the form of Z A sin B. A sin B is 3. So, I put 3 here and taken 1 by 3 outside. So, this is nothing but this term, and the denominator is same. So, what is the corresponding inverse? A to the power n sin B n. So, root 13 to the power n, and sin B n is, okay, I will write sin B n, where into of course u n, where B is equal to tan inverse minus 3 by 2. Is it okay? Another example we would like to take. Determine the region of convergence ROC of YZ, where YZ is given as the sum of x1z and x2z. x1z is given as z by z plus 1, x2z is equal to z to the power minus 2 by z plus 1. This will have an ROC z greater than 1. This is also having an ROC z greater than 1. What will be the ROC for this function? The function converges for this part outside the unit circle. For this part also it is outside the unit circle. So, the total sum will have a region of convergence normally. Let us see. Okay. So, add them together, what do you get? YZ z plus z to the power minus 2 by z plus 1. Okay. If I take z to the power minus 3 outside, minus 2 outside, then I will get z to the power 3 plus 1 by z plus 1, which gives me z cube plus 1 will have z plus 1 as a common factor. So, z squared plus z minus z plus 1, this minus, into z to the minus 2, which gives me 1 okay, minus z to the minus 1 plus z to the power minus 2. And what is ROC of this? When is it becoming infinity? Only at z is equal to 0. So, this converges, except the origin, it converges in the entire space. So, apparently the two functions x1z and x2z, though they were having a region of convergence outside the unit circle, the function x1z was converging only in this region, so was x2z, but the total sum converges except at this point in the entire space. All right. Let us see what will be the response, the impulse response of corresponding to yz. What will be x1n and x2n? If we add them together, what will be this? Z by z plus 1. What kind of sequence will it give? Alternately changing the sign, okay, and z to the power minus 2 by z plus 1, what is it? 0, 0, and then 1 minus 1, 1 minus 1. Is it 0, 0? Only 1 0? 0 0. So, this was z to the power minus 2. Oh, this is z by z plus 1. Thank you. This is z by z plus 1 will be, first one will be, second one it will be 0 0 0, then 1, because I have to take one more 0. So, if you add them together, so it is a sequence, first one is oscillatory, so is the second one with a shift, but shift of 1 2 3. So, now it is oscillatory. So, what will be the net result? It is a finite sequence, it is not an infinite sequence. So, it will converge. Okay. Sometimes it is a very good example, sometimes nowadays to reduce noise in any system, we have anti-noise. That means you create a signal which will be in anti-phase with the noise signal. So, you create another noise to cancel the parent noise, so that you have a silencing effect. You do not have to pad these, you do not have to have a wall, barrier wall to prevent yourself from the disturbing noise. You can create it by having just some anti-noise generators. All right. If you can know the source of the noise, actual noise, its behavior, if you can sense it with a sensor, and suppose the noise source is at a far off place and it takes so much time to propagate, all right, and you have a sensor there, it transmits a signal immediately. The moment the signal comes here, in that time you have already started the anti-noise generator, so that will be cancelled with that. So, you will be getting a signal free from noise. So, that is a very challenging task, scientists are working on it. So, this is a very good example of digital signal processing in a very practical situation. Let us take up another example. What will be the ROC what will be the ROC of YZ equal to HZ into XZ. That is, you are having XN and HN convolved, output is YN. So, in the Z domain it will be like this, where HZ is given as 1 by Z squared plus 7Z plus 10, okay, and XN is given as delta n plus delta 2 times delta n minus 1. That means you are giving an input of 1 and 2. This is 0, 1, this is Xn. What will be the region of convergence for YZ? So, XZ you can compute from here will be 1 plus 2 Z inverse. I can write this as Z inverse into 1 plus Z. Will that be all right? So, YZ will be, how much is it? Z inverse, it should be 2 plus Z, 2 plus Z divided by this, and you can factorize this, Z plus 2 into Z plus 5. So, that gives me Z inverse by Z plus 5. Okay. So, what is the ROC? One may take one Z common outside. So, that will become Z to the minus 2 divided by 1 plus 5 Z inverse. Is that all right? So, ROC should be 5 Z inverse should be less than 1, or Z should be greater than 5. Okay. Let us come to another example. Okay, I will take another page. Consider the signal Xn is equal to Un minus 3 Un minus 1. Okay, Un minus 1. Yn is equal to 3 to the power n minus 2 to the power n Un. What will be Hn? So, let us compute Xz. It will be okay, Z by Z plus 1. Z by minus 1, all right, minus 3 into Un minus 1 it is Z by Z minus 1 shifted by one step. So, Z inverse multiplied by this. So, Z inverse will get cancelled with this Z. So, it will be 3 by Z minus 1. So, we may take Z minus 1, Z minus 3. Is that so? How much is YZ? 3 to the power n. So, 1 by 1 minus 3 z inverse minus 1 by 1 minus 2 z inverse, which means z by z minus 3 minus z by z minus 2. Correct me if I am wrong. Is that all right? So, that gives me z minus 2 minus z minus 3. So, plus 1 by z minus 3 into z minus 2, and z can be taken out. Okay. So, Hz will be Yz by Xz. Is that all right? So, z by z minus 3 into z minus 2 into z minus 1 by z minus 3. Is this all right? So, that is equal to z into z minus 1 by z minus 2 into z minus 3 whole square. Make partial fractions and then take the inverse. Can you make the partial fractions? Let's see. A by z minus 2 plus b by z minus 3 plus c by z minus 3 whole square. So, A will be multiplied by z minus 2 and then put z is equal to 2. So, it will be 2 into 1 divided by 2 minus 3 whole square, that is 1. So, that gives me 2. Are you all getting that? C will be, I multiply by z minus 3 whole squared, then put z is equal to 3. So, it will be 3 into 2 divided by 3 minus 2, that is 1. So, that is 6. Okay. And B will be d dz of, after multiplying by z minus 3 whole square, that is z into z minus 1 by z minus 2, derivative of that. If I write z square minus z by z minus 2 and derivative of this at z is equal to 3. Is that all right? So, numerator will be z 2z minus 1 into z minus 2 minus z square minus z by z minus 2 whole square. Evaluated at z is equal to 3. So, 2z squared minus z squared, that is z square, 2z into 2, 4, 5 plus 1. So, 4, is that so? By z minus 2 whole squared, evaluated at 3. So, that gives me 9 minus 12. So, minus 3 divided by 1 squared. So, minus 3. Okay. So, we have got these 3 values. So, 2 by z minus 2 plus, sorry, minus 3 by, was there any mistake? I should have factorized, I told you, hz by z. Okay. So, 1 z should have been reduced. Okay. So, az by yz by z, first of all you should compute. okay, hz by z, hz by z, that is equal to z minus 1 by z minus 3 into z minus 2, z minus 3 whole square into z minus 2, which will be a by z minus 2 plus b by z minus 3 plus c by z minus 3 whole squared, okay, and you can compute a b c, that will be a is 1, all right, multiply by z minus 2, put z is equal to 1, z is equal to 2, so it will be 2 minus 1, 1, okay. Then c, z minus 3 whole squared, so it will be 2, and b will be, if I take the derivative of z minus 1 by z minus 2, so it will be z minus 1 z minus 2 into derivative of this is 1 minus z minus 1 divided by z minus 2 whole square, evaluated at z is equal to 3. So, z will go, this is minus 1 by z minus 2 whole squared, that is minus 1, is that so? So, hz, after getting this you multiply by z, so it will be az by z minus 2, which will be z by z minus 2 minus z by z minus 3 plus 2z by z minus 3 whole squared. So, what will be the corresponding hns? This is 2 to the power n minus 3 to the power n minus 2, is it 2 into n, z by z minus 3 whole square, is it not a ramp function, z minus 1, 2z by z minus 3 whole squared, is it not same? What is the z transform of a ramp function? Okay, n into a to the power n, how much is it? Z by z minus a whole square. So, what is this? So, it will be minus 2 into, it will be 3, it is 3 plus 3, it is minus, so plus 3 into 3 to the power n into n, and there is a multiplier 2, so into 2, okay, whole thing into un. Is it all right? The last one is, consider the signal xn equal to minus 1, 2, minus 3, 2, minus 1 with DTFT x e to the power j omega. Determine a, x at 0, b, angle of x at any frequency, c, minus pi to plus pi x omega d omega, d, x at pi, and lastly minus pi to plus pi x omega magnitude square d omega. Okay. So, we will take up one by one, at least some of them, rest of them I can leave it to you. X at 0, how much is it? Okay. So, all right, let us see what is x e to the power j omega first. It will be minus 1 plus 2 into e to the power minus j omega plus minus 3 into e to the power minus j 2 omega and so on, all right. And I am putting omega equal to 0, except 0 means basically I should have written e to the power j 0, okay. Omega is 0. So, it will be just sum of these terms. So, how much is it? If you add up minus 1, 2, minus 3, 2, minus 1, it will be minus 1. Okay. What will be the angle of this? Okay, let me write this completely. Minus 3 into e to the power minus then plus 2 into e to the power minus j 3 omega minus 1 into e to the power j minus 4 omega. Now, the sequence that has been given to you, you see, if you plot, is there any symmetry? Minus 1, okay, then plus 2, then minus 3, then again plus 2, then minus 1. So, it is a symmetric function, all right. If I take this and this, this and this and this, if I pair them, then it will be very simple. This is minus 1 and this one minus 1 into 1 minus e to the power minus j 4 omega. Oh, both are okay. Plus 2 into 1 plus e to the power minus j 4 omega into e to the power minus j omega, and minus 3 into e to the power minus j 2 omega. Okay. So, this one, if I take e to the power minus j 2 omega common, then that will give me twice cosine 2 omega into e to the power minus j 2 omega. Similarly, here if I take e to the power minus j 2 omega out, so this will be e to the power minus j 3 omega into twice cosine 2 omega inside, and there is a 2 here, plus 3 into e to the power minus j 2 omega. Okay. So, it will be minus 1 into e to the power minus j 2 omega 3 omega, sorry, minus, yes, second term is e to the power minus j sorry 1, and this I have taken 3 plus 1 minus 1. Okay. Let me rewrite this, it will be clear. See, minus 1 and this I have taken common. Okay. Actually, it is 4 and 0, so it is minus 2 e to the power minus j 2 omega into cosine 2 omega. Is that all right? First one. Then next one, 2 into e to the power minus j omega, 2 into e to the power minus j 3 omega. If I take e to the power minus j 2 omega common, so 4 into e to the power minus j 2 omega all right, into cosine omega. Is it all right? And then the next one is minus 3 into e to the power minus j 2 omega, all right. So, if I add them together, it will be minus 2 cosine 2 omega, which is a real quantity, plus 4 into cosine omega, which is a real quantity, minus 3 and multiplied by e to the power minus j 2 omega. E to the power minus j 2 omega, for any omega it is having an angle of 90 degrees, minus 90 degrees, and this quantity is real, all right. So, this will have an angle of minus j, that is 2 omega, so j will go, so minus 2 omega, its sign is basically 180 degrees, no sorry, e to the minus j 2 omega, I made a slip, e to the minus j 2 omega this is real, angle is 2 omega. No, there is some slip here, minus 1, actually minus 1 plus yeah, you are searching for the angle, okay, it will have minus 2 omega. I think we will stop here for today, we will continue with the other two parts in the next class. Thank you very much.